Who here works in cloud? We got like 4.5 people. That's cool. Who aspires to work in cloud? A couple more folks. Cool. This is strange. Well, we're working on it here. Oh, but we got another dongle potentially. It might be a dongle issue. Maybe I'll try a different port of the physical kind. No? I haven't tried that. The question was, have I tried to turn it on and off again? And haven't tried that lately. However, oh, we got another port here. Sometimes those insignia devices can be a little cranky. They can be a little temperamental sometimes. Would I allow, yes, I'm allowing that to connect, certainly. And then, okay, so this one, you think? Click on that guy, choose content, you think that makes sense? Okay, yep. Extended display. Okay, so now how do I get that thing on there? Do I hit maybe play? Do I do the play button? Play from start. Oh, so cool. All right. I appreciate all your assistance. Thank you so much for coming to my talk. GCP org policies to live by, and most importantly, their implementation pitfalls. The best thing about this talk is that you didn't have to go to RSA to watch it. Congratulations. I had to go to RSA to give it, but you folks had to come to lovely SecretCon. Much better deal, I'd have to say. Oh, and I haven't, yep. RSA would like you to know that this is for educational purposes only. Don't try to do this at home. They don't back anything that I have to say ever. Okay, thank you. Try this one? Great, okay. For those who don't know me, my name is Kat Traxler. I'm a security researcher with a company called Vector AI. When I joined, they were NDR. They spent a time being XDR. We are back to being an NDR company, everyone. I am a security researcher there. I spend my time mostly focusing on vulnerabilities in the cloud, which means doing a lot of bug bounty, a lot of kind of independent research. But this talk is not about vulnerabilities. It's more about the limitations of the preventative controls. Preventative controls that I used to spend a lot of times thinking about, designing, and architecting. So I know a lot about their benefits and how they can be used to help your environment, and then all of the pitfalls and bypasses and headaches that they're going to cause along the way. So you're going to see how great they are to implement as guardrails, but then you're going to also see all of the complications, how they can prevent abuse of the cloud, and then how they can also cause the prevention of legitimate use. I break this talk up into about 4 parts. To make this a little bit more exciting, a little bit saucier, we're going to have a narration through here of this fake company called Megacorp, who is migrating to the cloud and having to design some guardrails in their Google Cloud presence to try to put some constraints on their environment. Then I'm going to give you this really brief 101 on org policy constraints. This isn't a talk about org policy constraints and how they work. You can Google this. You can look at the documentation. What we're going to talk about are like a handful of really great org policies for you to implement today to get some really quick risk reduction. But then the exciting part is how that's all going to really kind of blow up in your face. And then finally, maybe some bright spots about how you can use org policy constraints instead of this like restrictive constraint. It's right in the name, constraint. But instead of using it instead of that way, instead using it as a goalpost, a shining light on the hill to work towards. It works a little bit better in your operationally with your people and processes. But before we do that, let's see here. Oh yeah, I want you to brace yourself because this is statistically a below average talk. According to my feedback at RSA, it's going to get really dry. The content potentially not bad, but it might not be very engaging. And then per the last comment, the beginning might be a little bit hard to follow, but at the end, it might all come together. So this is just fair warning for you that there might not be a so what. It might be very dry. It might even get kind of technical, and you might not be very engaged. Fair warning. Okay. Potentially, this is a story that you're familiar with. If you've worked in enterprise security, your company is moving to the cloud. Megacorp is moving to the cloud. Their developers are hungry for data, and their old data warehousing solution is out of date. They can no longer keep up with the hungry hippo of data. So they're moving to cloud, specifically Google Cloud, to have faster access to data. As a result, the security org is going to mobilize to try to understand what are the available guardrails. Like, what restrictions can they impose before anybody moves over to limit the risk before you even create a single workload? And that brings us to org policy constraints. This is the service within Google Cloud that's going to constrain, it's in the name, constrain, and create guardrails in your environment. The equivalents in the other cloud are Azure policy and service control policies in AWS. So these service control policies in AWS are the things that you can say that are like, only create an EC2 instance if it's in a specific region. If you really want to limit the regions that you operate in, say you don't want to operate in APAC, you don't want to operate in Europe, you know you're going to operate in certain regions, you're going to create a service control policy that's going to say only allow the creation of certain EC2 instances in certain areas. Or you can say prevent all access to all APIs unless it has MFA enabled, unless you have this tag that says you've MFA'd in. These are the kind of policies you can create in AWS. In GCP, it's going to be really similar, although because it's a resource-based policy, you're going to say things like only allow, hi, Mr. Kipti. You're ultimately going to say like only allow certain services to be enabled. It's like a very unique thing in Google Cloud. Not all of the services are enabled. Like when you walk into AWS, everything's enabled. In Google Cloud, you can say only enable certain ones. Or you can say like, if you're gonna create a cloud function, it has to be of this specific variety. This is like the specifics of it that has to be enabled to then prevent some non-conformant policy. So these megacorp folks are going to define the parameters around how they want their projects to look like. They're going to define the parameters around their service accounts. And they're also going to define the parameters of their policy bindings. They're going to say like exactly how IAM policy is going to be defined. And the basic structure looks like this. This is probably the dry part that everybody got confused of. I'm thinking this is it. We're going to have rules. Rules are going to enforce constraints that say, if I have an IAM policy binding, which are basically your permissions, that can only come from a couple types of principles. And these policies can have two different types. They can be either Booleans, which is like on or off. Like there's a type of org policy constraint that says allow principals to be exempted from logging. That's right, you can actually exempt certain principals from logging. Or you can say don't ever allow that. Don't ever allow principals to be exempted from logging. That's a Boolean constraint. It's either on or off. When you walk into your org policy constraint, or when you walk into your org, this is automatically off. So you can actually exempt principals from being logged. Turn it on, and then you say, you can't do that. The other type besides Boolean constraints are the list constraints, where you actually feed the parameters in and you say, these are the parameters that you're gonna follow. You can feed in parameters like, these are the only VPCs that you're gonna allow traffic to come from. These are the only Google Cloud services that you're gonna allow to be enabled in certain projects. It's a list rather than a Boolean. Okay, that was our 2-minute 101 on org policy constraints. Hopefully you'll understand the guardrails you can place around an organization, how you can shape it, how you can create it to mirror your policies. So next we're gonna look at a handful of predefined policies from Google that are really like heavy hitters as far as risk reduction. And Megacorp is looking at them from the perspective of what do we want to prevent? What do we want to prevent? Do we want to prevent ransomware? Do we want to create an identity perimeter? Do we want to create a network perimeter? So from this lens, we're going to say that Megacorp is going to create this greenfield environment. And the very first thing that they want to do is disable all of these risky defaults. Because they've heard the memo, you've all heard the memo, cloud comes with a lot of risky defaults. And one of the fun ways you can find out what the risky defaults are is actually just reading the predefined policies from Google Cloud. They publish, last I checked, 135 predefined policies that you can enable or disable. Just by reading through these things, you can say, well, I bet that's a risky default that they're giving their customers the option to opt out of. By reading through these, you can kind of understand what you might be, how you might be able to create your bespoke greenfield to be just a little bit better than the out-of-the-box one. You can tackle things like the default service account, and you can tackle things like the default network. So default service accounts. Automatically, when you enable some services, when you enable the compute service, when you enable the cloud build service, when you enable the app engine service, these services are automatically going to create a service account, and it's automatically going to be added the editor role at the project level. This has a lot of inherent risk, which I've talked about and many other people have talked about. Or you can just enable this org policy constraint, this Boolean constraint, and turn that off. The service account will still be created, but that binding will not be applied. Also, you can skip the default network creation. Whenever a new project is created within Google Cloud, the default network with some default firewall rules is automatically created. I mean, this is all just for speed of adoption, speed of use, so you can change that behavior with this org policy constraint. So this is right on top of Megacorp's list. We're going to create a nice and neat greenfield. Next up, they're really thinking about data exfiltration, specifically from external actors. So this is going to free up the security team to think more about data exfiltration from some other avenues, like valid access or malicious insider. But with org policy constraints, you can really think about that external path, the path from like open buckets, those types of things. So what do we do with org policies? There's a couple of them that you can do to create the identity perimeter. Oh, did I miss it? Data exfiltration, yes, okay. We can create an identity perimeter, yes. We can specifically define who is allowed to connect to our instance to our Google Cloud instance through workload identity. That's their OIDC Federation connection. You can connect in your Azure IDP, you can connect in your AWS IDP. With this list constraint, you can be very explicit about which IDPs, which accounts can connect in, further defining your identity perimeter. And then this one's gonna keep popping up, domain restricted sharing, because it's an extremely powerful org policy constraint. It's actually now enabled by default. So that's another really interesting thing to talk about, is that some of these are not originally enabled by default. Say they're a Boolean constraint, they're always turned off. And then at some point, there was a meeting, and they decided, hey, from now on, when people create new organizations, we're gonna actually have them enabled. So this behavior changed, I think May the 4th, 2024. That's why I remember these things. May the 4th, 2024, this changed that domain restricted sharing org policy constraint is now enabled by default. And what does it do? It defines the principals who can have IAM policy in your Google Cloud environment. So for Megacorp can only have principals with an @megacorp.com email address. It can't be an @evilcorp, right? And if they had created their organization prior to May 4th, 2024, they'd have to enable this. After May 4th, 2024, this would automatically be in place. So it's automatically just going to be megacorp.com is the only type of principal, user principal allowed to have IAM policy. Really powerful when creating an identity perimeter. I know it's really technical and in the weeds for some people who just want to draw boxes on whiteboards and be an architect, but this is incredibly, incredibly powerful org policy. And finally, restricting the types of authentication you can have into your cloud storage and preventing access keys. For those in the AWS world, this might sound obvious. In the Google Cloud world, this is much less obvious. It's going to prevent some type of persistence mechanisms. Okay. So Megacorp is creating their greenfield. They've prevented those, disabled those risky defaults. They've created their identity perimeter. What about their network perimeter? Identity perimeter, network perimeter. Do we still have a network in the cloud? Yeah, I think we do. Okay. Let's think about what we need to define to prevent all of those pesky open port issues within our CSPM. We're going to try to prevent that as much as possible to keep that noise down. Also to prevent some valid risks. So Megacorp's going to bring a block of IPs to their cloud deployment, and they want to have a list constraint that just says only those IPs that we're bringing to our cloud can be assigned to computes. And then we're also going to say that when you spin up a Cloud SQL instance, don't spin it up with a public IP. Seems like a pretty basic a pretty basic one to enable. There weren't many meetings about that one. They're like, yeah, check, done. Okay. And then they're going to make heavy use of containers, and so naturally they're going to be using a lot of Cloud Run, and they're going to define exactly what type of ingress, what type of network setting is going to be allowed with their Cloud Run. They're going to want to make sure that they're going to have internal type communications, and when you spin up a Cloud Run, they're going to say you can't create it publicly. It's going to say internal only. And of course, we're going to skip that default network creation. Oops. Okay. And finally, okay, so we prevented risky defaults. We created an identity perimeter. We've created a network perimeter. I guess there's a network. Finally, ransomware. It's on everybody's mind. What can we do to just prevent ransomware? What policies can we use to control who and how data is being accessed, along with what IAM policies are going to surround the data access? And it's not going to totally eliminate that 2 a.m. call, but here's a few policies that we can talk about that define access to storage buckets. The first one, enforcing public access prevention. This is just going to simply prevent buckets from being assigned the all users or the all authenticated users principles, these two special principles allowing public access. Prevent those two special users to being assigned access, preventing buckets from being made public. And the second one is actually preventing this sort of more archaic method for accessing buckets. Very similar to the AWS world, there's two mechanisms for accessing data within cloud storage, cloud IAM, the more modern and new way, and the kind of antiquated way with ACLs. Turn it off. This org policy constraint just turns off the mechanism for ACLs. You're not even going to use it. You're only going to use one mechanism, cloud IAM. And lastly, we talked about the buckets and we talked about object access. Now we're just going to talk about like guarding against malicious encryption. So we're going to have a couple different safeguards. We're going to say when you destroy a KMS key, here's what the minimum destroy schedule duration is, right? So when you hit destroy, it's going to put you in timeout for a little bit, and you still have 7 days to recover, 14 days to recover, something like that. And then perhaps you're going to be creating a crypto project, like a bunker for all of your encryption keys. And you're going to actually use a list constraint to just say, like, this is the only project that we're going to allow encryption from. We're not going to allow you to encrypt our objects from Evil Corp's project or this other random project, only from this bunkered crypto project that's authorized. This is going to prevent that malicious encryption from an attacker-controlled project. Okay, so in the recap, what have we prevented, or what have we really reduced the scope of? What are the classes of vulnerabilities we've done? Okay. We've eliminated the possibility of privilege escalation with this one particular mechanism by preventing overly privileged kind of automatic service account grants. We've initial access vectors via public IPs and management ports. Those publicly exposed resources, we put some constraints around those. We have prevented external actor exfiltration via IAM. And we are feeling pretty good about the accomplishments. Cloud native ransomware techniques, yeah. I mean, we have created a beautiful kingdom, and nothing ever bad should ever happen to our kingdom, let alone a workload. Don't you dare move a workload into our kingdom. So the sign is being opened. Google Cloud's open for business. You know, we've had 87 meetings last week on it, and we've created the perfect chef's kiss environment. Now everybody move on over and no complaints. But the next section is the fun section, which is the whole reason I created this talk. I didn't create this talk to educate anybody about org policy constraints. You absolutely can read that. I didn't even necessarily create it to talk about some of the most impactful ones, because I think that those maybe can be a little bit self-evident. I created it for this section. This is like the bummer section of like how it's all gonna break down. Implementation challenges when cloud gets real. Implementation challenges when your preventative controls fail you, or when they're just technically not possible and you have to create workarounds. Because as architects, we have grand visions, we have grand plans, we have hopes and dreams, and then usually that rubber meets the road somehow. So we've checked back in with Megacorp. Everything is beautiful, it's perfectly hardened. They've basically banned all of the risky configuration. Unfortunately, they've also banned a lot of actually legitimate use cases. Let's see here. Okay, the very first thing that they're having issues with as workloads start to move in is remote management, right? So we've prevented the default network from being created along with all of the default open ports. And so the infrastructure team is unable to remotely manage and troubleshoot any of these VM instances. Fortunately, the solution's actually fairly easy. It just required some foresight and a little bit of work on their end. The solution to this is IAP, Identity Aware Proxy. It's a unique service from Google Cloud, but basically what you need to do is populate all of the firewalls attached to all of the kind of bespokely created VPCs, populate those all with special firewall rules, allowing for, air quotes, backdoor traffic to Google's back end, right? So this is sort of like a private proxy service from Google that's going to allow your IT administrators with the appropriate IAM permissions and with the appropriate firewall rules to then proxy into your otherwise private internal resources. Again, this is not the end of the world, but if you don't plan for it and if you don't know about it, you have kind of a mess on your hands. Okay, so now to the identity layer issues that have been created. Remember, we prevented privilege escalation by preventing the editor role, and a very powerful role, from being automatically assigned to default service accounts. An excellent plan. But we didn't plan for a safe alternative, especially for cloud build, right? We had no safe alternative for an identity to be assigned to the CI/CD pipeline. So what's happening? Either there's unable to build code, or depending on the privilege level, developers are creating their own service accounts, attaching their own privileges to them, and then running them in every single project. And you have this proliferation, this privilege escalation issue within every single project. So by preventing that editor role assignments, they actually needed to create their own set of infrastructure to begin with. Again, this is solvable, but it's going to require a whole heck of a lot of work by creating your own kind of bunkered project of service accounts, your own bunkered projects that can be vended out to each one of your developers, each one of your build teams, to allow them to have these kind of one-off identities for the tasks that they want to use. You're going to have to implement your own processes and procedures to replace that default, that quick start that you've prevented. Not the end of the world, but also requires a lot of foresight and work. Oof. And now we've broken a valid pattern. As I mentioned, Megacorp knew that they were going to be heavily containerized, and they were going to be using a lot of internal services talking to each other, right? Maybe 10 years ago, kind of like during the serverless revolution, there was like the idea that you'd have all of these like serverless functions spun up kind of in private networks, all kind of ping into each other. Today, this is a lot of just like containerized services. They're going to migrate all of their backend APIs to this Cloud Run service. And the intention is that they're not internet exposed. They don't need any external connectivity. These are private APIs. So naturally, the org policy constraint they're implementing is saying the only network constraint that the only network definition they're allowed to have is internal. This is actually preventing a valid pattern, which is Cloud Run instance talking to Cloud Run instance, believe it or not. And I have a few, like the whole audience went, huh? I understand, right? This is sort of a head scratcher, because private Cloud Run instances can talk to pub subs, They can talk to tasks, they can talk to schedulers. These are all of like very common PaaS services within the Google Cloud. But an internal cloud run cannot talk to another internal cloud run without creating this whole VPC architecture that you actually have to create VPCs and create connectors and route that traffic through a VPC with this connector so that when it comes back through the cloud run, it's tagged as internal. It's a fun little architecture that I'm sure a lot of enterprises have had to create if they insist on having this very powerful org policy constraint. Oh, and another fun one. I told you that this org policy would come up again. Domain restricted sharing. As a reminder, domain restricted sharing is, let's say, all of my policy bindings define who is getting this permission, and that who is an email address, in this case, @Megacorp. So Megacorp is saying only people with the @Megacorp email address can have permissions and policy bindings. And then maybe we had an acquisition and we say, okay, minor corp too. And you can imagine this keeps getting tacked onto. But does this mean that we can't integrate with Google? And in some cases, it certainly does. Because there are some Google system service accounts that are going to be requiring policy into your Google Cloud environment. Let's say there is a team that wants to integrate with Firebase. There's a handful of system accounts, Google system accounts, that are going to need policy, and they're going to be prevented from this org policy. And they're going to need to open a ticket, and they're going to need to ask for, some one-off exceptions. I've documented over a dozen of these kind of like one-off instances where it's actually going to break Google integrations that are still using these kind of global system accounts. I don't find this one nearly as troubling, this issue with domain restricted sharing, because this one tells me that it's working. This one tells me that I put this constraint in and said that, you can only have policy from these domains. And we've created a backlog of tickets now with people trying to integrate and you can't integrate, but it's working. That's comforting. The next one is less comforting because it's silent. If you imagine the org policy service, you send a change off, and before that change gets implemented, it kind of goes through the org policy service and says, like, is this in violation of anything I have implemented? And the only thing I can really check for policies is that email address in the policy. And with groups are going to be assigned an email address. So, admins@megacorp.com. And that's certainly going to be not in violation of their policy. However, the group membership is not going to be evaluated, right? So in a totally different system, in another far off land, operated by another team that certainly does not talk to the Google Cloud team, is the Google Groups team. And membership within the admins@megacorp.com, that can be all over the place, right? So you actually, if you're leveraging groups, and I certainly hope you are, if you're leveraging groups, you actually can never know for sure what that is, what that membership is, without regularly scheduled audits, believe it or not. So maybe it's not as powerful as we would otherwise hope it to be. This is the final chapter of the talk. And if you're familiar with cadences of talks where they say, like, it's like the hero's journey, and like the last one is like, and now here's what you can do. There's a little bit of that. And this is maybe contributed to my low scores at RSA. I totally admit that. We secure the cloud that we have, not the one that we want. Absolutely accurate. Megacorp is now having to learn how to manage through these like rough edges and how they can balance their realistic usage versus all of their aspirational goals versus like the kingdom, the fiefdom that they have created. So the Slack channels are full, the cries from engineering and development are full, and they've had to adopt the guardrails. And how have they adapted the guardrails? And there's a couple mechanisms for doing this, just on a super practical level, like what happened. And likely what happened is this sort of caveman approach, the toggle method. Put like a trademark, the toggle method. Policies are not retroactive. They're a point in time evaluation. So if, say, a development team cannot integrate with a Google service because there's a system account that needs a policy and that's in violation, you can literally turn the policy off. You get on a Slack call, Teams call, you turn it off. Okay, add the policy, turn it back on, we're good to go. This, I mean, I can imagine what happens with this. Everything is very loosely documented. It makes audits impossible. Makes it impossible to track over time if that who authorized that non-compliant and conformant resource, and that if they continuously over time still have that authorization. Makes it rather impossible. And I'm imagining Megacorp doing this at first just to get by. But then I'm also imagining them saying, okay. I know we call it greenfield, but how about we call it like yellow field? And we create a real green field this time. And we have these like dual zones, these multiple enforcement zones. And we're always gonna have multiple enforcement zones. We're always gonna have our like prod, non-prod, developer sandbox areas. But in this case, we're gonna have areas with different types of policy enforcement. And likely what's going to happen is we're going to have this continuous state of migration from one zone to another. It's not going to be this one-off, I'm in the bad spot, now I'm in the good spot. It's, I've progressed through policy enforcement because I've been able to enforce a more and more mature environment. That's the best I can do for a happy ending, I'm sorry. Okay. I once heard, this was like so many years ago, that your security organization cannot exceed the maturity of your engineering and development teams. And what I've kind of come to believe is like a slight variation on that is that your preventative controls can't outstrip your business's ability to abide by them. Your preventative controls can't outstrip your business's ability to abide by them. So Megacorp had the best of intentions, but they didn't provide the secure alternatives. And so a slew of invariants were created, and it's cleanup on aisle 5 until the end of time. So how might we think a little bit differently about org policy constraints as opposed to crafting a kingdom, a fiefdom that we then try to enforce? This is definitely a product of RSA when I got into OKRs, but using them as goalposts, using them in your OKRs, honestly, as your key results. Saying if your objective is to strengthen your Google Cloud security configuration, just like something generic, like I want to be good at cloud. Your key results can be around implementing these policies in different environments. Achieve 100% enforcement of restricting the public IP address within production by a certain time. And you can have these as goals in your KPIs rather than your constraints within different environments, or your predefined restrictions, your requirements for people to even build an app. Let's see here. Oh, yeah. More. So hopefully this will encourage you to, if you have access to a cloud environment, audit your environment and see what kind of constraints are applied, whether or not you have Azure, you have AWS, you have GCP. Like, look at what constraints are applied and what the scope of them is, and try to understand, are there different environments? And then think kind of idealistically about, like, what more restraints could you apply at the different environments? And could you aspirationally apply those in 6 months, 9 months? What would it take? Would it require you to build a bunkered crypto project, right? If your goal was to implement the org policy constraint that says encryption can only occur from this particular project because it's currently the Wild West, well, in order to implement that constraint, you can then define the projects and the work that needs to be done in order to get there. And that's all I have for you. If you go to Vector AI and about author Kat Traxler, there's a whole slew of blogs that I have written. A lot of them are about GCP. If they're not about GCP, they're about the cloud. That's pretty much it. So I appreciate your time, everybody. I'll be around for questions. Thank you so much.